All right, well, good afternoon, everyone. This is Dan McEvoy at the Western Regional Climate Center and Desert Research Institute in Reno, Nevada. Welcome to the June edition of the West Watch. It's 2 p.m. I'm going to give it 30 seconds, another minute here, and see if we have a few more folks join, and then I'll get started. All right, I'm going to go ahead and get started. Well, thanks again, everyone who has joined and those just joining. Again, this is Dan McEvoy at the Western Regional Climate Center in Reno, Nevada, and the Desert Research Institute. So thanks for joining the West Watch today. Today is our climate and coastal updates from WRCC and the Regional Ocean Observing Systems. So I'm sure many of you have been on the West Watch before, but hopefully we have some new folks as well. And for anyone that is new or just wants a refresher, what is the NOAA West Watch? And this is now a monthly webinar series designed mostly for NOAA staff and partners across the region, mostly to share information about climate anomalies and observations, and not just the observations, but the impacts to different systems across the West. There are two formats now for the West Watch. The one you're seeing this month is the climate overviews, and then we rotate on and off every month. So next month there'll be another webinar that has a specific topic lined up with several different presenters on that topic. So just a little bit of housekeeping before we get started today. I think I forgot to check with Joe, but if you have that poll question, we're just going to have the audience quickly answer a poll here about have you attended the West Watch previously or not. So please take just a few seconds to answer that poll. It should be popping up on your screen. All right, so thanks everyone for answering that. We have 51%. These are first-time attendees, so it's great to have new participants. So thanks again for all the new folks and those who have joined previously. So we'll move on to the rest of the housekeeping. Let's see, did I lose the sharing of my screen? Joe, are you still seeing my screen?
Yep, still seeing it.
Okay, sorry, I don't know what happened there. Okay, there we go. A little hiccup there. All right, well, we have several speakers today, about 10 to 15 minutes per speaker, depending on the topic. If you do have questions, there is a chat box on the right-hand side in the panel, on the tool panel. You can enter questions in there. We should have time for a brief Q&A after each speaker as well. If you want to, you'll have time to unmute yourself and ask questions then, or you can save them for the end if we have a little time for questions and discussions. This will be recorded, and there is a website where this will be posted for future viewing, and then there'll be a post-webinar survey sent out, and any feedback would be greatly appreciated. Before I move forward, I forgot to acknowledge that this is in collaboration with Joe Casola, the Regional Climate Services Director, who is back behind the scenes today, but runs the topic-specific webinars that will be next month. Okay, so on to today's speakers. I will be starting off with the climate brief and outlook, and then we'll have several presentations from our regional ocean observing systems partners. in the north, central coast and south coast. And so we'll move from north to south down the coast today. And so I'm going to jump right in. We got quite a bit of content, so I want to get into the climate update and outlook today. Let's see here. All right, so I want to start off just with a snapshot of the recent climate anomalies. So these are temperature and precipitation anomalies for the past 30 days ending on June 17th. On the left, we have precipitation as a percent of average, and then on the right, we have temperature anomalies. And so we see a few patterns show up. We start off with the precipitation patterns. A few things stand out. One thing that's somewhat concerning is the dryness along the coastal parts of the Pacific Northwest, as well as Washington and northern Idaho, much below average precipitation. It looks pretty bad in California for that anomaly and southern Arizona, but this is the dry season for that area, and so those anomalies are actually quite small in that area. But then the wet anomalies showing up are in the interior in the Great Basin, as well as central eastern Colorado and northeast New Mexico, where they really needed the precipitation, has been quite wet over the past 30 days. The temperature pattern on the right is a bit more spatially coherent. We have much above average temperatures over the last month in the northern northwest and northern Rockies, and then the southwest has actually been quite cool over the past 30 days relative to average. I did want to mention, so that precipitation map ended on the 17th of June. There was there currently is a storm moving through the northwest and will eject out further east into the Great Basin and the Rockies. That did bring some beneficial precipitation over the last 3 days to Oregon and Washington, anywhere from about a half inch to an inch and a quarter, a little bit more than that in the Cascades in Oregon and Washington. So this was welcome, and it's been much colder. Anyone who's on the West Coast right now knows it's much colder than it normally is for this time of year, thanks to this deep, cold, low pressure system. And so that's going to help things out a bit in the Northwest, but not alleviate the issues that have been ongoing for the past several months that I'll describe here throughout the talk. So if we take a step further back and look at the spring as a whole, so these are the on the left now, the rankings going all the way back to 1895 based on the PRISM data set for spring precipitation on the left and then spring temperature on the right, and that's March through May. And so generally it's been quite wet and cool with a few exceptions across the entire Western US. And this has really been helpful in alleviating the drought conditions for most places. We do still see some dry areas in Washington and again the northern Rockies there in the bottom third of the distribution, or even drier than that. But across California, the Great Basin, parts of the upper Colorado, lots of places in the top 10% of the distribution going all the way back to 1895. And again on the right, this persistent cold that's shown up pretty much throughout the entire water year has been really beneficial. A lot of areas below normal, even a few areas that had record cold springs. And so this is had a record cold spring. And so this is really helpful in minimizing the drought, or reducing the drought impacts, and also reducing the fire danger going into summer. There are still a few warm areas, again, those places that were also dry in the northern tier of the Pacific Northwest and parts of Arizona and New Mexico. But I really wanted to focus a bit on what happened in May, and it was a very hot month, relatively speaking, for the Pacific Northwest. So on the left, this is showing the May observed temperature rankings. Each little flag there is a long-term climate station, and all those ones are showing where it was the warmest May on record for that location. And so just an extremely warm May. Once you got about south of Idaho and Oregon border, things were much more normal, or even a little bit below normal in some places. And so this heat wave, May heat wave across the Pacific Northwest, or series of heat waves, is the same pattern associated with the really warm temperatures that have been increasing the fire danger across Canada, and making the fire danger and impacts worse from those fires in Alberta and other parts of Canada. And you can see that a temperature anomaly map from ERA 5, just showing how large those anomalies were across, those warm anomalies across Canada. And so one consequence of those warm temperatures have been a really quick loss of snow across really a lot of the US, but it was really only causing problems in places that's, you know, peak snowpack was near average or below average. And so I don't have a snapshot of the peak snowpack, but a lot of the West had a much above average snowpack, with the exception, again, of the northern parts of the Pacific Northwest and Northern Rockies, where they peaked, you know, near average, maybe even slightly above average in some places. And so, whereas in Sierra Nevada, Utah, Great Basin, it was near record snowpack for a lot of places. And so the map on the left then, this is showing the change in the snow water equivalent, or the SWE, between April 30th and May 31st. So how much snow melted out during the month of May. And any of those red dots are places that saw the greatest amount of snow melt for May on record, and orange is second most snow on record, snow melt. And the blues are the smallest amount, or if there was any SWE gain, but there are no blue dots on that map. And so we saw a lot of really fast loss of the snow across the entire West. But again, the Sierra had a really deep snowpack, so did Utah, the Great Basin, Upper Colorado. So it wasn't a problem there. Where it really was a problem was across the Pacific Northwest, and mainly Washington, Northern Idaho, Northwest Montana, and Northwest Wyoming. And so the map on the right is showing the anomaly of the meltout date, when the last bit of snow melted out at these stations. In any of those red dots, the snow has disappeared more than 2 weeks earlier than average, and the blue dots are where it's disappeared more than 2 weeks later than average. And so we had the heat wave and the dryness and the rapid meltout, loss of the snow, leading to this early meltout, which will give the soils more time to dry out, increase the drought impacts and fire danger going into summer. And so, as I mentioned, the Sierra Nevada was one place that had near record or record snowpack in some places. And there's still an awful lot of snow left for this time of year, particularly in the central and the southern Sierra Nevada that are higher in elevation. The image on the left is just from a few days ago from MODIS satellite image, showing just there's still a ton of snow left there in the Sierra. I picked one of the locations in the central Sierra Nevada, Levitt Lake. This is a little bit north of Yosemite, near Sonora Pass. There's still over 80 inches of snow water equivalent at this location, which is over, you know, much more than the peak that normally occurs in late April. And so there's more than a full year's worth of average snow melt to melt out in this area still. So still lots of snow going into the streams and reservoirs, and flooding has also been a concern throughout parts of California. So in terms of what this winter did for erasing or improving or deteriorating drought conditions, I'm now showing the latest drought monitor map from June 13th, which was released last week. And I also putting in a little plug here to check out the NITUS, the snow drought conditions update, which was released, the last one for the season was released on June 15th. I help out with the group there in writing up these monthly reports throughout the snow season. And so we've released this water year summary talking about the snow conditions, but also pointing out how the big snowpack in those areas that I talked about helped to eliminate a lot of the drought that was present there a year ago, except for a few isolated areas like the Pacific Northwest. And so we see there is still some drought on the map, but if we look at how much it's changed over the past year, so currently about 15% of the area of the West is in drought, and there is no part of the West that is in D3 or D4 drought right now. And if you go back just 1 year, we had 77% of the area was in drought, with 38% of the area in D3 or D4 drought. So really big improvements, mostly from the snow season, but the cool conditions also helped mitigate some of those impacts. And so really the main concerns going into summer, again, I'm going to kind of keep hitting this point, is the Pacific Northwest and parts of the Northern Rockies. That map there on the left is showing the changes in the drought monitor over the last 4 weeks. And you can see in Western Oregon, Washington, there's been 1 and 2 class degradations in drought. Also in Northwest Wyoming, Southwest Montana, there's been some degradations. But then just not far from those degradations, there's improvements in Oregon as well, those green colors. And so in Oregon, there's really a pretty sharp gradient between where things are improving and deteriorating going into the summer. But then just a few snapshots of some of the inputs that, why the drought is getting worse in this region. You can see on the top right are the stream flow percentiles that are in drought conditions. So a lot of areas, less than 10%, less than 10th percentile, some at record low levels for the 28-day stream flows. And then on the bottom right is the soil moisture anomaly. And so you have these underlying dry soils on top of the really warm May and really fast snow melt and subpar snowpack for a lot of those areas. And so again, that's the place of biggest concern. And so in terms of how much more or how much water we've seen from the runoff and how much we could expect going into the rest of the summer, we have the observed and forecast runoff here from the NRCS at the Huck 6 basin level. And so on the left is the water year from October to May. This is at a percent of median. And the blues and greens are above average runoff, and the yellows are below average. See, a lot of the West did see above normal runoff throughout most of the water year, with exceptions of coastal Washington and Oregon, but it wasn't too bad of a year. But things change as we move forward going into June and July and head into sort of the low flow seasons there. Much above average flows still projected for the Southwest, the Sierra Nevada, Colorado River Basin, which is great. But again, those flows really drop off in northern Washington, Idaho, and northwest Montana, again, where the most drought concerns are going to be this summer. And I did want to touch on Lake Powell and Lake Mead in the Colorado River Basin. This winter was very beneficial for the area, particularly with the short-term drought impacts. It did bring a lot of water into the streams, and it's doing the best it can to fill the reservoirs, but Lake Mead and Powell were extremely low before this winter, and it's going to take a lot more than just one winter to really bring those up to even near average, if not above average. And so currently Lake Powell, what I'm showing now, is at 37% of capacity. These are the traces of the storage in acre feet. And I've shown the last few years. So it was lower last year, and there's been a pretty substantial rise this year, which is really great to see. But it's still lower than 2020. And if we look back just a little over 20 years ago in 2000, we can see it was nearly full. And so this is the challenge of just how much water has been lost over the past 20 plus years. But again, this winter has been very beneficial for the upper Colorado Basin. And a similar story for Lake Mead, that's currently at 31% of capacity, but higher than last year, getting some good water in there this year. But again, nowhere near being full and where it was about 20-25 years ago. Last thing to touch on is the fire danger. So we're getting into the fire season. It's been somewhat quiet in the Southwest, Arizona, New Mexico, which starts earlier than a lot of other places around the West. And it's expected to stay that way at least through June. And so up on the upper left is the wildland fire potential outlook for June that was issued on June 1. And the greens are places where below normal fire activity is expected, and the reds are places where above normal large fire activity is expected. And so we see that little area in Washington and Oregon in red there. And then on the right, I've shown where the current large fires are, and they actually line up very closely to where that outlook was showing. There's a cluster of current large fires in that area. And again, this overlaps with the drought area and other areas of concern that I've been discussing. And as we move forward into the summer, the outlook will change a bit. These are the fire potential outlooks for July on the left and August on the right. And we see for July, the red areas expand across much of Washington, and parts of the northern northwest Great Basin, but the Sierra Nevada still showing that green, and Northwest California, which is a good sign. And then moving into August, it doesn't change a whole lot other than eliminating some of the below normal in the Sierra Nevada and Northwest California. So we would expect above normal fire activity across a lot of the Pacific Northwest this summer based on these outlooks and what the conditions have been like. And so quickly, I want to run through the ENSO update that I think a lot of people have been hearing about and thinking about going into summer, and of course, as we move into next fall and winter. This info right here is from the Climate Prediction Center from this morning's update. There's currently an El Nino advisory, which has been in place for a couple weeks now, but this is the first time that they've posted they are observing El Nino conditions. And so the map on the right is showing the sea surface temperature anomaly. You can really see the central equatorial Pacific starting to heat up in that classic El Nino signature of those warm anomalies. And the atmosphere is responding consistent with weak El Nino conditions. And the CPC expects that this will gradually strengthen in the Northern Hemisphere going into the winter of 2023-2024. And if we look at the forecasts from the Climate Prediction Center and the IRI, there's pretty high confidence that El Nino will continue to develop and strengthen. On the upper left are the probabilities of El Nino neutral or La Nina going through the seasons out into next winter. And we see those red bars, pretty much every season is almost above 90% chance of El Nino, very, very tiny chance of neutral and no chance at all of La Nina during that period. And then on the bottom right is showing the individual models, just showing there is some spread, but for the most part, they're showing a moderate to potentially strong El Nino developing by fall or winter. And so even at this point, in time, it's really hard to say what that will mean for the seasonal outlook. Typically, there isn't a huge connection between ENSO and summer conditions. It tends to have more impact in the winter and following spring in terms of our weather that we get in the Western US. But for the summer, here's the seasonal outlook for July through September. Not a huge surprise here. We've seen a lot of this. We'll see how it plays out given the fact that we've been in this kind of cool trend across a lot of the West for the past several months. But there are higher probabilities of above normal temperatures for this period, particularly over the Southwest where the highest probabilities are showing up. And precipitation, there isn't really too big of a signal except for in the monsoon region in Arizona and New Mexico where there's about a 40 to 50% chance of the precipitation being below normal for the bulk of that monsoon season based on this outlook. And so I will stop there, and we have quite a bit more to cover, and maybe see if there's a question in the chat, and if not, we can move on to our ocean conditions. Joe, do you know if we have any questions right now?
Yeah, no questions so far, but I encourage folks to put them in, and we can field them during our breaks.
Great, thank you. All right, so I'm gonna switch it over to our next presenter, unless Joe is able to do that. Okay, great. So Anna Boyer and Jan Newton, this is going to be a recorded presentation. Anna is on the line, so I will let her introduce. Thank you.
Yeah, hi, my name is Anna Boyer. I'm with NANOOS, and I'm going to play a video that Jan pre-recorded. Yeah.
Hi, everyone.
Anna, I think we lost your...
But we really wanted to share with you
now?
the latest results. So let's
Now
take a look.
Yes.
Okay, I'll start over.
Thank you.
Yeah.
Hi, everyone. This is Jan Newton. Sorry I can't be there in person with you. Anna Boyer from our team is and will be available for questions. Both Roxanne and I had the same meeting, and so, but we really wanted to share with you the latest results. So let's take a look at what's going on in the NANOOS Pacific Northwest region. So first, before we do that, let's put it in global context. Here are typical slides showing the global ocean, water temperature, heat anomalies. So the difference between current and average, as expressed as a monthly average, shown here for March 2023. So this is sea surface temperature, red being the warmer than average colors. And so the patterns that we've been seeing are the blue remnants of the La Nina, the dying La Nina at the equator, a little bit of a hint of strong red there off the west coast of South America. And then in the North Pacific, kind of a pattern where we have warmer than average temperatures offshore in the North Pacific, and then cooler than average towards shore. So that was the situation in March. As we go to April, that kind of just intensifies. But when we come to May, we see that in the North Pacific, the temperature patterns anomalies are kind of muting somewhat, reducing, and we see the development of the stronger positive anomalies at the equator. This is the average for May, and in June, NOAA declared that we are in a La Nina state. Okay, so in terms of the North Pacific and how it might affect our regions, here is the marine heat wave analysis showing pretty dissipated and primarily moderate signals, and so not really influencing our region at this point in time. All right, let's take a look at the buoys. Here we see the NDBC buoys off the Washington coast, well offshore, and the blue being the signal relative to the black line, which is the 45-year average with standard deviations as you see plotted. And so the signal was trending upward, and then there's a gap in the record, and but since that gap, been pretty much average, a little hair under one standard deviation above, but pretty standard temperatures, sea surface temperatures for this offshore site. And that makes sense with what we saw with the satellite and the marine heat waves. Now, as we get closer to shore, there's a lot more variability. And so here you see NDBC buoys up and down the coast, stretching into Northern California. And we see much more variability, but we do see a consistent feature that I'll show here in that red circle with the very strong positive anomaly that you see crossing the 2 standard deviation line up in the Pacific Northwest, Washington, and Oregon. But that consistent signal, which coincided with a heat dome, those are the dates for the Pacific Northwest. I'm sure you heard about it earlier, but that was a very significant event, and one that we saw in the sea surface temperature record. Okay, now shifting to Puget Sound, so leaving the coast and coming into our major inland sea, Puget Sound, Salish Sea, we have profiling buoys, and here you can see the depth resolved anomalies, same color scheme, where we started the year with cooler than average waters. That was consistent with the La Nina conditions off the coast. But in about mid-May, we shift to warmer than average water temperatures. And you can see that that signal starts at the surface and then extends downward. That's highly suggestive that this is also in response to with downward mixing, and it's impressive how the signal gets transmitted in both of these areas, one in Hood Canal and one in South Sound, because they're very different in terms of their degree of stratification and other features. So this is a pretty powerful signal. Shifting to salinity, we see a little bit of a different pattern. So we see saltier than average conditions over the water column for both of these stations, which has been consistent with lower than average rainfall. But you see some strong negatives, so fresher than average patterns at Tuano in the surface. And so what could be causing that difference? Well, we have a new product that is hosted on NANOOS, a Puget Sound metrics dashboard that was developed with climatologist Nick Bond and oceanographer John Mickett and others. And if you look inside the red circle, you see this is adjusted river flow, and you see very strong above normal river flow into the canal and not in South Sound, which is consistent with that salinity anomaly signal we just saw. So what could be causing such a strong river flow? Well, my hypothesis is that given the timing of this, this also could be due to the warmer than average temperatures we've been receiving and some snow melt that is influencing this river flow into Hood Canal. All right, now shifting gears to talk about waves, we'll go back out to the upper coast. And Roxanne Carini introduced this topic last time, and we're going to carry it forward. And so the arrows are pointing to some high wave events that were observed in May and June. You can see that the rest of the record is fairly normal for the season. And then if we go to those inshore buoys, we see that it was really the June event that is notable, and very notable for the season. It is greater than 2 standard deviations above the mean, actually much greater than 2 standard deviations above the mean. So we really had some strong wave action in this nearshore environment during June. And I know that's the case because we had people trying to deploy buoys that were definitely challenged by these conditions. Okay, so to summarize, we have seen La Nina dissipate and the arrival of the El Nino. In terms of marine heat wave, it doesn't look to be anything sensational in the North Pacific at this point in time. And the coastal buoys are showing pretty average conditions with the exception of that May period that was associated with the heat dome on land. In Puget Sound, we saw further evidence of this atmospheric heating and possible influence on both temperature and salinity, and offshore wave events with particularly high ones nearer the shore in June. So with that, I'll say thank you so much, and Anna can take any questions, and I'll hope to see you next time. Thanks again. Bye-bye.
Yeah, I'm happy to take any questions they're making.
Yeah, thanks, Anna, and virtual recorded Jan for that. That was great. I don't see any questions. I don't know if I'm looking in the right place, if Joe or others see questions.
No, it's still quiet out on the questions list.
All right, maybe we'll have some more questions at the end. But again, thank you, Anna, and we'll shift down the coast to Alex Harper at CeNCOOS. So take it away.
Thanks, Dan.
See your screen.
You can see my screen.
Yes.
Okay. Let me get it into presentation mode. How does that look?
I'm still seeing your presenter view.
Okay. Let me try that once more. Still?
Yes. If you go on from that view in the display, oh, there you go. Now it looks good.
Does that look okay?
Yep.
All right, let me hide myself. Okay, great. Sorry for the hiccup on my end. Thanks so much for having us again from the Central and Northern California region based out of the Monterey Bay Aquarium Research Institute. I can advance my slides here. Okay, so we usually start our update with just the latest news, things that are rising to the top of folks' interests in the region. And as mentioned in Dan's wonderful update, we've had some unseasonably cool and somewhat unsettled weather in Central and Northern California over the last few months, and particularly on the Central and Northern coasts, largely driven by some of these atmospheric anomalies, as Dan described. El Nino advisory has been announced, that conditions have been observed, and this is something that's also being tracked closely here in the region, and any impacts to us locally. And of course, the headlines around global ocean warming and marine heat waves and anomalies seen in the Atlantic Ocean, the Gulf of Mexico, and elsewhere. While the California coast has largely been spared by those hot temperatures. Made a little GIF here of, this is the West Coast Ocean Forecast System. These are real temperatures, not an anomaly, just from the last year. It's moving a little quick, so sorry to make you dizzy. Oops. But what you're seeing is starting in the past year and into the summer of 2022, get those deep red, pretty warm temperatures and right up along the coast. And then starting in November and through the winter, there's a large scale cooling pattern. But in the last month or so, starting in May, you do see a warming offshore and increasingly up along the coastline again. So general warming pattern, but really striking how dynamic the coastal ocean temperatures have been in this past year. So here's a look of the past 180 days from our shore station network, starting up in Trinidad, which is way up north in California. You see sort of generally normal temperatures. There's some spikes, some warm anomalies, but generally around normal after this sort of prolonged cool period, which is observed at all three of those sites from over the winter months. In Bodega Bay, the site run by UC Davis Bodega Marine Lab, you start to see more pronounced warming in the past month or two. And Moss Landing Marine Lab, there's a bit of a warming trend in recent weeks as well. Looking now at the NDBC buoys, the mooring off of Point Arena on the Mendocino coast after a data gap this winter, picked up that overall cool trend through the late winter and early spring, and remains cool now until into June, while the Monterey and Cape San Martin buoys are also trending warmer. So a bit of a north central coast distinction there. Now looking at the Monterey Bay glider temperatures, and Henry showed this last time in April, and I think the notable thing is that these these red surface temperatures are getting a sort of a deeper red and extending deeper into the water column. And so we'll look at that same glider line again here, but now we're looking at temperature anomalies, distance offshore, and so you have to remember these plots are at different scales. So generally, what you see offshore of Monterey from April through June is a general warming trend. Temperatures are getting warmer and penetrating deeper. And then in the bottom seasonal anomaly plot, you can see in May and June, there's a patch of red for this anomalously warm water mass around 50 to 100 meters offshore. And you also see that that warm water is extending deeper into the water column. This is our, not ours, Jaycox and all upwelling indicator, but a visualization that we at CeNCOOS have been producing for the last few months. In the top panel, both Cutie and Beauty suggest perhaps anomalous upwelling pattern, sort of in the northern coast and extending into Oregon in June, probably driven by strong winds. But in the bottom panel, these anomalies, you're actually seeing some anomalous weakening of the upwelling signal, that those blue those sort of blobs into 2023, suggesting sort of strong upwelling, and then and also a strong weakening, relaxation of the upwelling signal. Here's a heat wave indicator that we've shown recently. It's sort of taking you through, if you can see the date, up through June, and then it'll take us 3 days into the future, a forecast. And popping up here is this this heat anomaly along the coast of central, sort of south central California, which is interesting and a bit unanticipated, at least for me. But now we're going into the forecast, and it's suggesting that this warm anomaly along the coast will dissipate. Looking at the NOAA marine heat wave tracker, you can also see in the left-hand figure this warm blob sort of tightly located along the south central coast. So we'll watch to see if that abates in the next few days. There's a bloom reported in San Francisco Bay that we've been tracking. It's deemed to be not harmful, but perhaps an active start to the season there. And lastly, we're sort of co-hosting through the California Current Acidification Network a marine carbon dioxide removal webinar this Friday, and I encourage folks to attend. Thanks very much.
All right, thank you for that, Alex. Excellent information as always. There is one question. It really could be, I think, for any of the ocean observing folks. So Megan and Alex are on the line right now. The question is, are there any short-term impacts while the conditions change from La Nina to El Nino quickly? And then the question goes on to the short-term impacts on the coastal conditions. Either you have any thoughts on that question while Megan's getting ready?
Well, I think, Dan, you mentioned that typically we'll see, if we do see,
To make me presenter. Sorry.
no, go ahead.
Is my screen sharing?
Yeah,
Yes,
Oh,
it
it
is.
is. Okay, good.
but we can see your calendar and your slides.
Oh, goody. Everyone wants to see what's going on.
Typically, we'll see El Nino impacts in the winter or fall season.
Let's see.
So I'm not anticipating seeing.
Okay, so you're saying similar
Along
to
with
the
this.
kind of atmospheric response that I was talking about, probably similar to the coastal response, that you see more of that in the winter and spring. All right, thank you. That was the only question I'm seeing. Megan, your screen looks, I see your full screen, but we see kind of
Trying to see.
part of your other screen.
No. I can't see what you guys see. And
I think if you just present
I don't
your
even know what
slides, it'll go.
I'm in presenter view. That's why it's weird.
Now we see your background, full screen image.
How about this?
There we go.
Okay.
Yeah.
All right. Little trial and error. Okay. Well, thanks everyone. I am Megan Medina. I am the CeNCOOS program coordinator, and I'm going to give you a brief update on what's going on in our region, and then I'm going to turn it over to Jim Burns at CEDA. So mainly, I just want to take a moment to talk about the current ongoing event in Southern California and Central California. So we have this domoic acid event. We regularly talk to the various stranding centers in California, both Northern and Central and Southern, and with this large network. And so we've been getting emails alerting us that there's been a lot of dolphin stranding, specifically in the Channel Islands, Santa Barbara, Ventura region, as well as south in LA and Orange County, a few in San Diego as well, and some more central in Morro Bay and Monterey area. So, but it definitely seems to be emphasized around the Ventura and Santa Barbara counties. We've been in contact with the Channel Islands Marine and Wildlife Institute. They're definitely overburdened. They're receiving 50 to 100 calls an hour with stranding events, stranding reports. They're responding to as many as they can. They only have so many volunteers. There's definitely burnout's a real thing. And so right now they're prioritizing the yearlings, those who have been less exposed, and bringing them in for rehabilitation. Unfortunately, a lot of the strandings have just had to remain where they are. It's kind of what are we, and I did want to point out here, the NOAA Fisheries put out a new map with the Marine Mammal Training Center with the hotline of all the numbers on one map. So on the left, in like the coastal area, shows the numbers you would call if you detect a live stranding, and the ones that are kind of showing overlapping with the inland is showing the number of the lines you would call if you found a dead stranding. So we're actively monitoring this. I did post, we helped put a story out through Fisheries. I encourage you to take a look. As far as what we're doing to help monitor the bloom in the event, we have our weekly shore stations monitoring, mostly at piers, with both CeNCOOS and CeNCOOS. This definitely seems to be an offshore event. Many of the marine mammals, they forage offshore, so they're considered indicator species of what might be happening. Yeah, as far as Stearns Wharf, again, at our weekly net tows that we collect, it's either missing it or again, this event truly is offshore because we aren't detecting any bloom. And so CeNCOOS, in collaboration with our colleagues at SWRP and UC Santa Cruz and the Marine Mammal Center, we're writing a proposal for NOAA and Coast Rapid response funding. We did this last August, September for a similar event. So we're hoping to get funds through that so we can process some of the tissues from the strandings. Oh, and then I wanted to point out here, I also am displaying a GIF of the sea harm model. So this is the California Harmful Algae Risk Mapping Tool. And this is showing the probability of particulate domoic acid. And as you see in the areas that are bright red, that's the higher likelihood that there's going to be domoic acid in the area. So we're definitely seeing it in the Southern California region, specifically around, like I mentioned, Santa Barbara, Ventura, and LA and Orange County as well. I'm gonna go a little bit faster through these to give Jim some time and leave time for questions, but we are seeing anomalously cooler temperatures in Southern California at our automated shore stations. So these are variables of temperature and salinity, chlorophyll, and pH and dissolved oxygen at some of our sites are measured in near real time. And then I know we've been talking a little bit about this looming El Nino event. As far as our glider lines show, temperatures are rising slightly at both the equator and here. So this is showing in make sure I have this right. So we have this line 90 is here in red. And you can see it's a slight uptick in temperature as well as at the ONI index. So these two coinciding, last time this happened was 7 years ago during the last El Nino event. It's still showing slightly and obviously cooler temperatures at line 90 at 50 meters, but we are, we're keeping an eye on it. We'll see what happens, but we are, as Dan mentioned earlier, predicting an El Nino in 2023, winter 2024. So we will continue to keep you updated on this during our webinars. Last thing I wanted to mention, we have this bipartisan infrastructure law funding. It started December 1st, but we didn't actually get our funding until later this spring. This will be 5 years of funding, but right now we have the first 2 years, and we're putting this funding towards recapping and hardening infrastructure for our surface current network, our gliders that I mentioned previously, adding some bioeco sensors onto the gliders, updating equipment at our weekly shore stations that are real-time shore stations, as well as our imaging flow-sided bots. I wish we have an IFCB dedicated at Stearns Wharf, but unfortunately, due to technical issues, it's actually been offline for a couple months. We hope to get out there soon. This would have been great to have out there to capture this potential DA event happening. And then a new initiative is we're funding Chris Lowe's lab to deploy 4 new real-time acoustic monitoring buoys. So this will send alerts to the lifeguards or anyone who has downloaded the app, real-time alerts when a tagged animal swims by the buoys. And with that, I'm going to turn this over to Jim. So Jim, do you want me to just keep it on mine, or you want to take over?
You can just keep on rolling. Thanks.
Okay.
Is my audio coming through? I guess I am. Okay, so hi, I'm James Behrens, sometimes known as Jim Behrens. I am the program manager at CDIP. We're primarily funded by the Army Corps of Engineers, but we have deep partnerships with a lot of IUS regional associations, in particular for these stations. Eric Terrell and Sophia Merrifield are also private principal investigators on the CDIP program, wave observation program. Next slide, please.
Mm-hmm.
Oh, and that last photo is one of our buoys going out off of the Golden Gate Bridge, in case that wasn't obvious. So we're involved in precision wave monitoring for both real-time conditions and for validation of wave models. We operate a California wave model, both in nowcast using real-time buoy data, as well as forecast mode using global wave models. And we have a discretized output for various coastal research projects. Coastal engineering impacts, erosion of the coast through wave activity are motivating factors here, as well as understanding total water level and coastal inundation alert systems have been built off of this. Next slide. This is the present extent of the CDIP wave monitoring buoy array. We have 85 stations, and a little more than half of those are in collaboration with various university groups and IUS regional associations. We're across the Pacific, up and down the East Coast, but you can see we have a concentration on the West Coast. This program was founded at Scripps in the 70s and has grown from this location here in Southern California. Next slide. Our California wave model uses the buoy information, not just the CDIP buoys, but also the Weather Service buoys. Feed this, and we have these output locations for the along the shore for cross-shore transects, and this gives you wave information going back to 2000 and is constantly updated and has forecasts. So all this information is available for the coastal research community. Next slide, please. We maintain the stations. It's a lot of hardware, nuts and bolts, ropes, chains, diving operations. The buoys accumulate fouling, obviously. And so we have our team and our partners working to keep the stations working at full spec and maximal uptime. Next slide, please. Some of the new stations on the West Coast, I thought it might be helpful to point out where these are and why. For some context, Green Beach and Red Beach were installed with Marine Corps funding. This is to inform amphibious vehicle testing at Camp Pendleton in particular. But the nice thing with the Green Beach station, a little bit offshore there, is that it plugs a hole in our ability to force the coastal wave model after Dana Point was a former CDIP station that we lost a couple of years ago. So this has benefits for the modeling of the coast beyond just the Marines' use. Standing up specialized displays, the buoys now are measuring currents. If you look over there on the left, we've got this kind of setup where we're showing various wave models, the real buoy data, the direction of the incoming waves at the stations, and then the surface current as a time series at those two different stations. Next slide, please. The surface currents are part of the data sets from these CDIP buoys in more and more locations now, and we're doing research here in our team about wave current interactions with the co-located information. Another new CDIP station location is Pajaro Beach. This is with the California State Parks. The flip side of this is that CDIP 254 Point Santa Cruz is going to be decommissioned in the coming months. It's part of the same funding program to sample the wave climate at various coastal locations for inundation work. The Coastal Processes Research Group team here at Scripps is making coastal measurements of the wave run-up and LiDAR drone measurements of the beach erosion. We're also tying this in with a wave shoaling research project with an Army Corps funded station that'll be out there temporarily too. Next slide, and I'm just about done. This last place I want to point out, up in Oregon, the Army Corps is installing one off of Tillamook to inform the jetty stabilization and channel dredging that occurs there. It's also a very hazardous location for vessel operations, and so the maritime safety aspect will be significant there as well. That yellowish line in the middle is showing that there's a large sandbar off of the harbor there in Tillamook that needs attention, and so this monitoring program will be motivated by that, but then again, we have the benefits for all coastal stakeholders. Over in Newport, the NREL DOE project for the PacWave wave energy converter testbed is moving forward, and we're installing wave riders there too. Next slide. And so just to wrap it up, the West Coast wave activity, we've been following seasonal trends in general. Jen pointed that out as well. Up north, after an active winter, we saw some major, if you look over there on the bottom left at Point Reyes off of Central California, the atmospheric river events in early part of the year brought historically powerful waves. We're kind of following the the mean more or less lately, with a few of those stronger events that Jen pointed out also recorded in California, but nowhere near the sort of maxima that we've seen historically. San Pedro down in the middle at the bottom there, we've been seeing very weak wave activity in the Southern California bight with very little south swell coming through. Then the sea surface temperatures have been up and down, hitting extremes in both the ends of the thermometer lately in some of our West Coast stations. And so there's a little flavor of how we end up with these CDIP stations, and thanks for your time.
All right, well, thank you for that, James and Megan and all the other speakers. We are pretty close to, or we are right at the top of the hour at 3. I don't see any other questions. If there are questions, you're welcome to put those in the box or ask questions right now. It's been a pretty quiet crowd today. But I just want to thank everyone again for participating, and for the presenters. Oh, we might have one question here. We do. This is, oh, that's a long one. Let's see here. So this question says, is there some place we can see a long-term history of coastal wind events, many fall and winter? My impression in Seattle is that the frequency of strong wind events with gusts 35 to 40 knots has increased over the past decade. We've seen more tree damage and tree falls also elsewhere along the northwest coasts. So if the ICE folks are still on, I guess, are there long-term wind data with these buoys?
Hey Dan, this is Alex. There is wind is collected at a bunch of our sites. I bet if you go on the NANOOS portal and search for wind data, you'll be able to find a solid time series, whatever exists. And maybe Anna, you have a idea of which sites have the longest time series.
Yeah, I'm not sure which ones in particular, but if you go onto our climatology app, you can bounce around from different buoys and look at the time series.
Well, great. Thank you for that. Not seeing other questions.
I'll just mention NCEI is also a place where you might find archived environmental time series. All of our stuff gets archived there, so it's a good place to look to.
Thank you. And then we're wrapping up here, and so Joe, I don't know if you had a plug for the date of the next West Watch before we send everyone off.
Yeah, thanks, Dan. Thanks to all the speakers again for another excellent job. The next West Watch will be on July 18th, and our theme is going to be atmospheric rivers. I tried to time it at a time when there would be, of the year, when there'd be almost zero chance of real atmospheric rivers, so we can talk about it in a safe space. Yeah, the advertisement should be coming out in a week or so, but thanks to audience for hanging in, and thanks to all the speakers for another excellent job.
All right, thank you, everyone.
Thanks, Dan.